You just learned Azure Load Balancer. It's brilliant for distributing raw traffic. But it has a hard limit. It works at layer 4. It sees IP addresses and port numbers. It does not read your HTTP requests. It can't say, send requests for /API to these servers. It can't say, block this SQL injection attempt. It can't say, terminate HTTPS here and pass plain HTTP to the backend. That's exactly what Azure Application Gateway does. Application Gateway works at layer 7, the HTTP layer. It reads your actual web traffic. URLs, headers, cookies, host names. And it makes smart routing decisions based on that content. 2 different tools. 2 different jobs. Load Balancer for raw TCP and UDP traffic. Application Gateway for web applications. By the end of this video you'll know exactly when to use each one. Let's start. Let me walk you through the architecture of Application Gateway. Think of it as a pipeline. Traffic flows through 5 stages. Stage 1, the front-end IP. This is the public IP address that all your users connect to. Everything starts here. Stage 2, listeners. A listener sits on a port and waits for connections. You define whether it accepts HTTP on port 80, HTTPS on port 443, or both. One gateway can have multiple listeners for multiple sites. Stage 3, routing rules. A rule connects a listener to a backend pool. When a request matches this listener, send it to that pool. Rules can be basic: one listener, one pool. Or path-based, /API goes here, /images goes there. Stage 4, backend pool. Your actual servers. VMs, scale sets, app services, even external IPs. Stage 5, HTTP settings. How the gateway talks to your backends. Which port? Which protocol? Whether to use cookie-based affinity. This is the control panel for the last mile. Listeners are where traffic enters your application gateway. And there are 2 types. You need to understand both. A basic listener accepts all traffic on a port. No hostname check. Port 443 gets a request, basic listener grabs it. Use this when you have one website on your gateway. A multi-site listener is smarter. It checks the HTTP host header in the request. Is this request for contoso.com? Route it here. Is it for fabricam.com? Route it there. Here's the powerful part. You can run both types on the same gateway. Same public IP address. One gateway handling traffic for 5 completely separate web applications. Each one gets its own listener, its own routing rules, its own backend pool. Multi-site listeners are evaluated first. The basic listener is the catch-all. If no hostname matches, it gets the request. This is how companies host dozens of apps on a single application gateway. One IP. One gateway. Multiple sites. Clean. This is where Application Gateway becomes really powerful. A basic routing rule is simple. Everything coming through this listener goes to the same backend pool. One rule. One pool. Done. But path-based routing is what enables real microservices architecture. Example. Your app lives at contoso.com. Your API runs on Node.js servers. Your static images are served by a separate service. Your checkout process uses a different backend entirely. With path-based routing. Contoso.com/API/anything Node.js backend pool. Contoso.com/images/anything image server pool. Contoso.com/checkout/anything checkout service pool. Everything else default front-end pool. One gateway. One domain. For completely separate backend services. And your users never know. They just hit contoso.com. This is how you build a clean microservices API gateway. Without managing a separate routing layer. Application Gateway handles it all. SSL is expensive. Not in money, in CPU cycles. Every HTTPS connection requires a TLS handshake. Asymmetric cryptography. Certificate verification. Key exchange. All of this happens before a single byte of your application data moves. SSL termination offloads this work from your backend servers. Here's how it works. Your client connects to Application Gateway over HTTPS. The gateway decrypts the traffic. It then passes plain HTTP to your backend servers. Your backends never see HTTPS. No certificates to manage on each VM. No TLS overhead on your application servers. The gateway handles all of it. Now, some workloads can't do this. Healthcare. Finance. Compliance requirements mandate encryption all the way to the backend. For those cases, use end-to-end SSL. The gateway terminates the client connection. Then re-encrypts the traffic before forwarding to backends. You get centralized certificate management and backend encryption. SSL termination in production. End-to-end SSL when compliance demands it. Your application has vulnerabilities. Every application does. SQL injection. Cross-site scripting. Command injection. Path traversal. OWASP lists the top 10. Attackers know all of them. The web application firewall sits in front of your app and blocks these attacks before they ever reach your code. WAF is built into Application Gateway as an optional SKU. Enable it and every incoming request gets inspected against the OWASP core rule set. A request contains what looks like SQL injection, blocked. A request tries cross-site scripting, blocked. Your application never even sees it. Here's the smart way to deploy WAF. Start in detection mode. It logs everything that would have been blocked, but doesn't block anything. Review those logs for a week. Make sure there are no false positives matching legitimate traffic. Then switch to prevention mode. Custom rules let you go further. Block traffic from specific countries. Block known bad IP ranges. Rate limit by IP address to stop brute force attacks. WAF is not a replacement for secure code. It's a defense in-depth layer. One that catches what slips through. Application Gateway can do more than just route traffic. It can transform it. The most common use case you'll implement on day 1. HTTP to HTTPS redirect. Any request arriving on port 80 automatically redirected to port 443. One rule. Done. No code change on your app. But rewrite rules go much further. You need to add security headers to every response? X-frame options, X-content type options, strict transport security. Best practice requires them. Developers forget to add them. Set them once in the gateway. Every response gets them. Always. You want to hide your server technology from attackers? Remove the server header. Remove X powered by. Don't tell attackers you're running IIS 10.0. Strip those headers at the gateway before the response leaves. URL rewrite is another powerful option. Incoming request for /products/123. Your backend expects /API/v2/items/123. The gateway rewrites the URL. Your backend never knows the difference. All of this. No application code changes. Let me talk about running Application Gateway in production. Because dev settings will hurt you at scale. Application Gateway v2 supports autoscaling. Traffic increases, the gateway automatically adds capacity. Traffic drops, it scales back down. You only pay for what you use. But here's what catches people out. Autoscaling takes time. Around 6 to 7 minutes. If you get a sudden traffic spike, a viral moment, a marketing campaign, the gateway might be slow to respond while scaling up. The fix is straightforward. Set your minimum instance count to at least 2. Preferably matching your normal traffic baseline. This eliminates cold start delays. And always deploy across availability zones. Zone 1 fails, your gateway instances in Zone 2 and Zone 3 keep serving traffic. Health probes detect the unreachable backends. Traffic redirects automatically. The production template is simple. v2 SKU. Autoscaling enabled. Minimum 2 instances. Zone redundant. That's a gateway that handles whatever gets thrown at it. Before we wrap up, you need to understand where Application Gateway fits in Azure's networking portfolio. Because there are 4 services that sound similar. Azure Load Balancer. Layer 4. Regional. TCP and UDP. Use it for non-HTTP workloads or internal tier-to-tier traffic. Azure Application Gateway. Layer 7. Regional. HTTP and HTTPS. Use it for web applications in a single Azure region. Azure Front Door. Layer 7. Global. HTTP with CDN and Anycast routing. Use it when your users are worldwide and you need the closest edge to serve them. Azure Traffic Manager. DNS-based. Global. No data plane at all. Use it to route DNS queries to the right region, but it doesn't touch your actual traffic. Here's the decision tree. HTTP Web App, Single Region Application Gateway. HTTP Web App, Global Users, Azure Front Door. TCP Workload or Internal Load Balancing, Azure Load Balancer. DNS Level Global Failover, Traffic Manager. Many production architectures combine them. Front Door globally. Application Gateway per region. Load Balancer for internal service-to-service traffic. Each tool has its lane. Now you know them all. Let's finish with monitoring and cost, the 2 things people skip until they regret it. Monitoring Application Gateway. Watch the failed requests metric. Anything above 0 needs investigation. Watch healthy host count. A drop means a backend server just went down. Enable access logging. Every request gets logged: URI, response code, backend IP, latency. That log is your debugging lifeline when something breaks at 2 a.m. If you're using WAF, watch the WAF metrics dashboard. How many requests are being blocked? What rules are matching? This tells you if WAF is catching real attacks or blocking legitimate traffic. On cost, Application Gateway v2 charges 2 things. A fixed capacity unit per hour, think of it as the base cost of running the gateway. Variable capacity units based on your actual traffic volume. Watch your minimum instance count. Every instance you set as minimum runs all the time. 2 instances minimum is right for most workloads. Don't set 10 if you're running a small app. And that's Azure Application Gateway. Layer 7 routing. SSL termination. WAF protection. Autoscaling. You now know exactly when to use it and how to set it up right. Next up, Azure DNS and Traffic Manager, global routing at the DNS layer. Keep going. See you in the next one. Let's break this down logically. The route path works, so the gateway itself is running fine. SSL is working. The default listener is working. The problem is specifically on the /API path. This is a classic path-based routing problem. First thing to check, your path-based routing rule. Is there a rule that matches /API? Is it pointing to the right backend pool? Second, check the backend pool for the API servers. Is the health probe passing? Application Gateway shows healthy host count per backend pool. If it's 0, the gateway has marked all your API servers as unhealthy. No traffic goes there, which is exactly what you're seeing. Third, check HTTP settings for the API backend. What port and protocol is the gateway using to talk to the API servers? Sometimes the gateway is configured for port 80 but the API only listens on 8080. The health probe would fail. The servers would be marked unhealthy. Exactly this symptom. Active recall, path-based routing failures are almost always a misconfigured rule. Or an unhealthy backend pool on that specific path.